Hello everyone, in this lesson we will discuss what are the steps for designing beam. Beam are really one of the most important elements in structures because they are used to support the weight of floors, ceiling and roof of a building, and to also transfer load to a vertical load bearing element of the structure. So because of this, we need to properly follow the steps to design beam. Now here are the steps for designing beam. Step 1, we need to compute the factor moment on the beam. You will assume the self weight of the beam because we don't know or we don't have a clue as to what the beam look like. Or you can use this table for ACI requirements for minimum thickness, or you can just guess the value. Step 2 is we are going to assume phi equal to 0.90, which is the strength reduction factor, and we can compute the required nominal moment Mn, which is Mn required is equals to Mu divided by phi. So phi is the strength reduction factor while Mu is the ultimate moment. Step 3 is we are going to calculate rho for design. So rho is called the reinforcement ratio. So the formula for that is 0.18 then multiply Fc prime divide Fy. Fc prime is the compressive strength of the concrete, while Fy is the tensile strength of the steel. Now step 4 is we are going to calculate BD square. So this is how big the beam needs to be. So this is the formula for BD square required. Now the next step, which is step 5, is based on the assumed B over D ratio, which we mostly choose from 1.5 to 2.0, we can calculate a required B value. Now step 6, we are going to choose B and D value for a trial section. So you will select dimensions to the nearest 1 inch increment using this table. And the total height of the beam can be conservatively taken to be H equal to D, which is the depth of the beam, plus 3 inch. So 3 inch is the cover requirement. So this is to protect the beam from de-icing salt or to protect the beam from corrosion. So step 7 is based on the selected dimensions. We are going to compute the amount of tensile reinforcement, that is the required area of steel. So the formula for that is rho design then multiply B multiply D. So the next step, which is step 8, we are going to choose a reinforcement pattern that meets minimum beam width requirement. So we are going to keep the pattern as close to the required area of steel as possible using this table. Now the last step, which is step 9, is we are going to analyze the trial section to verify assumption. So what you are going to do is you are going to make sure it meets ACI requirements. That is phi Mn, which is the design nominal moment, should be greater than Mu, which is the ultimate moment. So the beam is safe if phi Mn is greater than or equal to Mu. And if not, you need to go back and change some parameters. So maybe you can change the depth of the beam, or you can change the weight of the beam, or the unit area of the material, or maybe you can reduce the load acting on the beam. That is by changing the tributary area to make sure phi Mn is greater than Mu. So if you can achieve this, you have successfully designed a reinforced concrete beam. So these are the steps for designing a reinforced concrete beam. So see you in the next lesson, and please don't forget to subscribe to the channel. Bye bye.